Okay, this week we will continue our lecture and workshop on the regression and its applications. And I need to apologize because although this week's agenda is the prediction of brain age using MRI data, but I think from the last week we only show how to do the simple linear regression. And I think it's worthy to continue our workshop on the multiple linear regression and complete our analysis on medical insurance data. So I plan that we will introduce and illustrate how to do multiple linear regression in the first half of the class, and then we will continue our journey to the prediction of brain age using MRI data. Okay? And also, I need to apologize because the 2 weeks ago, I forgot to upload our presentation materials onto our laboratory website. So now, if you log on to our laboratory website, and remember that you can just click on links, then you will see there is intelligent healthcare and its applications. Then the password is the IHA 2020. Then you should be able to download the slide materials 2 weeks ago, including the lecture and the workshop part. And also you can download the medical insurance data, which is a CSV file. So you can open this file with the Excel, and also I already show you how to analyze this data using MATLAB. Okay, so before we continue showing how to do multiple linear regression, I think I want to just give a very quick review that what is the generalized machine learning workflow, and this workflow can be applied to almost every model that we used in this class. Okay, so if you have a data, and the data should contain the multiple observation of a patient or individual or something, then the question is that we need to build a model to predict a response based on some observations. So to do this, then we want to divide the data into the training and the testing subset, because once we build a model in the training data, then we can evaluate the model in the testing data and to see how this model based on the training data work in the testing subset. So this is the most important part in almost every machine learning framework. So the next step would be we use the training data to build a model, and the model is dependent on what question you want to ask. For example, in our previous workshop, we used the medical insurance data, and the question is that can we predict the medical insurance expense based on the demographic profiles? So that is the question of the regression. And suppose if you have some imaging data, just for example, like I showed you in the first 2 lectures, then the question could be, can we build a model to classify the normal chest X-ray and the chest X-ray with the pneumonia findings? Okay, so the model is really dependent on what question you have in mind, and so be careful that we need to select a corresponding or appropriate model that can fit into your data. Okay, so in this case, we will use linear regression model, and that includes a simple linear regression and a multiple linear regression. And once we build a model, then we need to first evaluate this trained model in the training data. And it's because that the model, the data itself could be very dirty. So although we can build a model just based on the data, but the model itself probably just work very poorly. So the first thing we need to evaluate is that how model work in the training data, and that can be done by measure the error of the predicted value and comparing to the actual value. For example, in our workshop case, the evaluation could be a comparison between the predicted insurance expense and the actual insurance the value. So that is there's an error or difference between these two values, and then we can use this error to evaluate the model. And larger error could mean that the training model doesn't work very well, and that reflect the or indicate that maybe we need to rethink about the rationale behind the model training. So for example, maybe the linear regression is not useful in our case. Then we need to find out then what regression could be working better than our linear regression model. And the answer could be the nonlinear regression, could be like other machine learning methods, for example, like support vector machine, or the random forest decision tree, or like deep learning. Okay, so the third step is also very important because we want to know if the model is right. And suppose the model is right for our data, then we can use this trend model to predict response in the testing data. So this can be done because we assume that the distribution of the variable characteristics is very similar between the training and testing subsets. And so if we have a good model in the training data, we should be able to see similar results or similar errors in the testing data. And that is also very important because if you find that the error in the training model is relatively acceptable, but then you found that the error of the trend model, when you apply the trend model to in the testing data, you find the error is huge, then you probably will think about, what happened? So the most common answer is that sometimes we will have a very good training model, just fit perfectly to the training data. But that is overfitting because it just fit when we do, for example, in a linear regression, it may just find an answer that is dependent on the training data itself, but in reality, it cannot be applied to the testing data. Then in this case, you will find that there's a difference between the error, difference in error between the training data and the testing data. Okay, so the fourth step is important because we need to evaluate whether there's an overfitting in the training model, and we can apply this training model in the testing data to evaluate these kind of things. Okay, the final thing is that we want to evaluate the model performance in the testing data, and that is also the things that we want to know because we want a model that is very accurate. So even if we have a model in the training data with accuracy of 90%, but we also want a model performance in the testing data have the same performance. Okay, so that is the whole machine learning workflow, and this can be applied to almost every machine learning framework we used in this class. and also can be applied to the question you have in your data. Okay, so this is the overview of the machine learning workflow. Okay then, so if you understand the rationale behind the machine learning workflow, then I just give a very quick overview of the data we have in these two workshops. So this data can be downloaded from the kaggle.com, and this is one of the machine learning data sets provided in the public domain. So this data is medical cost personal data sets. And so it's just a CSV file. It's very simple and it's quite small. It's just 54 kilobytes. And again, so in this data we have 7 variables. We have age, sex, BMI, which is body mass index, and the children, number of children, smoking status, and the regions, which is the insurance region, and also the insurance charges, which also the insurance premiums. Okay, so you can see that in United States, the healthcare insurance is very high. So, and it's also very important that for insurance company that they want to develop a model that can accurately predict the insurers the outcome, and they can decide how much money they should collect from the insurer's pocket. Okay, so it contains around more than thousands of the insurers' data. Okay, so we can use this data to build a model based on a simple linear regression, which in the previous workshop we only used information of age and the insurance premiums. But in the multiple linear regression, we want to include more variables. So that is the whole point of the multiple linear regression. So let's just give a very quick review of our codes used in the previous class. So the first thing we will do is to read the data into MATLAB, and the function we use is XLSRead. And in this function, we just need to give an input of the file name, and then it will output the numerical results, the textual data, and the raw data. So everything in this CSV file, which is if the thing's number, will output into the raw data, but only the numerical data will output into the non-variable, and all the string data, which is the text data, will output into the TSD variable. Okay, so in the last class, we use information only age and the insurance, which we can extract from the first column of the non-variable and the seventh column of the non-variable. Okay, so remember that we need to check out what's the position of a particular variable, so you don't want to make an error in extracting variables. Okay, the second thing is that we just try to visualize the relationship between the age and insurance claims. And also, it should be the insurance premiums. I will modify this later. Okay, and the next thing is we try to fit the simple linear regression model to this age and insurance data. And we can visualize the predicted result. So in this line, we have a model 1, which is the results of the regression between age and insurance. Then we use this model to, given the information of age, then we can calculate what is the output of this model. Then we can visualize the regression results using a plot functions. Then we can also evaluate the root mean square error of this model. And also, for the machine learning framework, then we will follow the principles I show you in the first slides. Then the first thing, we need to divide the data into the training and testing subsets. And to do this, we will keep the ratio of the training and testing to be 7:3. So in here, then we just using the 30% of the case to be the testing data. Then we can create an index where one is the training index and the other is the testing index. And this index is just try to locate which case would be classified as the training and which case would be classified as the testing. Okay, so then we can divide the data into the training data and the testing data. And here I also want to make a correction that in the previous class I forgot to put this data, the line 32 here in my presentation. So with this data equal to age and insurance, then you can divide the data into the training and testing. And you can specify the training index equals to 1 or testing index equals to 1, then you will know that which case should be put into the training and which case should put into the testing. Okay. Then the final thing, the most important step is try to fit the model using the training data. So in this case, we use the first column in the training data, which is corresponding to age. If you remember that in the here we put the age in the first column, and the response is the insurance premiums, so which is the second column in the training data. And then we want to evaluate the response in the testing data. Then we use this training model, the trend model, then apply to the test data. Then you can figure out what is the predicted insurance premiums based on the testing, the age information in the testing data. Then these two lines, we will show you how to compare the root mean square error in the training model and the testing model. Again, I want to make a correction because in my previous presentation, in the previous class, I incorrectly used the sum in this part, the line 42. And remember, the root mean square error is that you need to sum up all squared difference and take a mean and then take a square root. So in the previous class, I erroneously used the sum here, but I didn't take the mean. So here, I just change the sum to the mean. Then you will calculate the average of the difference between the actual data and the predicted data. Then so this would be the correct formula for calculating the root mean square error. So in the previous slide, I show you that the error is large. This is because I used the sum, not the mean. Then you will find that if you use the mean, then these two values should be very close. And I also I want to emphasize that because in the line 28, because we use the rand sample functions, so you should expect that your results will be different from mine because this rand sample will give the random results each time you execute this code. So if you have a different subset using a random sample, you should derive the different models and different predictions. And but overall, you should have a comparable errors compared to what I gave you in my slides. So that's just want to keep in mind that these rand sample functions will just randomize everything. Then so each time you execute this code, you probably will get different result, but which when they should be all comparable. Means that the accuracy and the error, the level of the error should be comparable from one to the other. So that is the a brief overview of the code I gave you in the previous class. Okay, so in this class, obviously I want to include more predictors in the multiple linear regression model. Then remember that in this data we have 7 variables, and one is the response, which is the insurance premiums, and the other 6, then we only use 1 in the previous class. But now we want to use all of them in the multiple linear regression model. So when you look at the table, you should be able to find that some of the variables are continuous variable. For example, the body mass index, which is the continuous numbers. So continuous variables means that it is an analog measurement of something. For example, the body mass index is defined by the weight divided by the square height. So it is just can be any number, but not any number, but just a range. For example, maybe just between 15 to 35. Okay, so the continuous variable is very useful in a regression because you can evaluate the relationship between 2 continuous variables like age or BMI and the insurance premiums. So BMI is the 3rd column in the numerical output. So I just extract this BMI information by assigning the 3rd column of the non-variable into this BMI variable. Okay, so there are other variables that's not really continuous, but they have the ordinal information, which is they have order information. This is the number of children. So in this case, so one may just have no child, but some people may have 1 child or 2 children, 3 children, or even more children. So that is you can also think that this is a continuous number, but the number cannot be very large because probably the one may have more than 10 children, but that is very extreme in the modern society. So you can expect that the difference between the ordinal variables and continuous variables is that the ordinal variables are usually have a small range, and it's a very discrete. It's just like 0, 1, 2, 3, 4, 5. So it has a particular order, and that order has some meanings, which is in this case it means a number of children. So the children information is in the 4th column of our table. So we just extract the children information from using the num assigned the 4th column. Okay, so for the others, and they are category variables. But for the category variables, we can think about there are 2 cases. The one is the binary variables, which means that this variable contains only 2 states. For example, the smoking status only contains 2 states in our case, which is the smoker or non-smoker. You may argue that there are more status in the smoking status. For example, maybe the recent smoker, or the past smoker, or current smoker, or just something like non-smoker. Okay, so but in this case, we only define the smoker as a smoker or non-smoker. So we don't know whether this individual is a current smoker or past smoker, but they are all considered smoker. Okay, so in our table, the smoking status is a binary because it's only specified the smoker and non-smoker. Then we need to convert this smoking status into the 0 and 1. Okay, so to do this, then the first thing we need to extract the string variable from the TXT output of the Excel CSV file. And you can see that in the CSV file, then it contains the first row, which specifies the name of the variable. So in the TXT output, it also contains the name of the variable. So we cannot use this like just non-numerical variable just from the first element to the last element. In the text output, because it contains the name of the variable, so we need to extract the variable from the second to the end. Okay, so the first dimension, I just want to specify, I want everything from the second position of the table, second row of the table, and to the final row of the table. And the column is the fifth column in the table. So this will give us this string output of the smoking status. Okay, so I just want to switch to the whole screen view of my presentation, and you can see the insurance.csv file here. So you can see that, as I said, there are different types of variable here. So the one is the age, and the third one is the BMI, and the final one is the insurance premiums. And these three variables, age, BMI, and charges, are continuous variables. And the sex and the smoker and also regions are categorical variables. And the children's the children variable is the ordinal variables. So the difference between the continuous or orders and the categorical variable is that there is no intrinsic order in the categorical variables. I will explain this later, but for now, you can see that for the smoker variables, it has only yes or no, means that it has a smoking status or non-smoking status. So, so the first thing we need to extract the data from the second row to the last row. So that's why in my presentation, then I just the first line is try to extract this information into a string type of variable. Okay. All right. So the second line is try to convert this yes or no status to the number of 0 and 1. So in this case, I want to specify the yes to be the number 1, and for the others to be number 0. So in this case, I can just use the string compare functions, which is str, cmp, and these functions can compare any strings in the smoker string. If the case is the yes, it will specify as the 1, and for the others, we'll specify the zeros. So this is just a very simple presentation that how you can convert the string variable into the numerical variable by comparing a specific string in your case. So you want to convert all the result of the yes to the number 1, and for the others to be 0. And this can work in a binary variable because I have only 2 status, so it's either 0 and 1. Okay, so I can show you how to do this in the MATLAB. Okay, so in the MATLAB, then you can see that in the TXT, the data here, which is the text output of the XLS read, you can see that it contains only the text variable or string variable, which is the sex, smoker, and regions. So for the smokers, I already show you that in our code we should extract the second row to the last row in the fifth column. So I just try to execute this command, and you can see that there's a smoker underscore string variable appeared in the workspace, and the dimension should be the 1338 by 1 cell. And the cell means that it contains the string variables, which is yes or no in our case. Then I want to convert this one to like 1 as a yes and 0 as a no. So it should be converted to 1 0 0 0 0 0 0 0 0 0 0 1 0 0 1 and 0 0 0 0 1. So but in the small data, then of course you can do this manually. You can just convert by just for example, you can just type into 1 0 0 something like this one. But in our case, we have more than 1,000 cases, so it would be very slow if you just change this manually. So I want to find a way to automatically to convert the string data to numerical data. So I will just try to execute this line, which is the compare the smoker string. If the case is yes, it will be the 1, and the other would be the 0. So the manager just very quickly do our job, and then you can see the result is what we want. So likewise, you can do the same thing in the sex variable, because in the sex we have only male and female. Of course, you may argue that we have more definition of the sex, but this is a biological sex. We could just, in the most cases, we can define as a male and female. Okay, so the sex string is from the second column in the table. So we can extract the second row to the final row in the second column of the table. Then we can use the same principle that we can specify the male to be the 1 and the female to be 0, and using the cell function and string comparison functions. So it should give you the sex variable contains only 0 and 1. Okay, so the last variable we want to include in our multiple linear regression model is the regions. So I just paste the part of the region data in this slide. So obviously that this region data is categorical, means that it has the different distinct category in these region variables. So in this case, we have 4 regions, which is divide the United States into the southwest, southeast, northwest, and northeast. So in these kind of categorical variables, there are no order information. For example, there's no intrinsic order that you can specify the southwest as 0, southeast as 1. Maybe you specify the northwest as 2 and northeast as 3. But really, there's no meaningful information in this kind of order. So you can also specify the northeast as the 2, and for example, northwest as the 3, and the other is and so on and so forth. So this 0, 1, 2, 3 has no particular meanings in the regression. And if you just arbitrarily assign the 0, 1, 2, 3 into the regression model, it will give you a very odd result. So in a categorical variable, we should create some dummy variables. Okay, And before that, we just want you to know that there is no intrinsic order in categorical variables. So it's not logical to assign the ordinal variables in these categorical variables. So actually, the categorical variables, we usually call them nominal variables to differentiate with the ordinal variables or continuous variables. Okay, so the first thing we cannot use the ordinal data to replace the categorical variables. But how do we do this in the regression? So we need to create some dummy variables. The dummy variables means that we want to test each region one by one. But in this case, you probably immediately think that we have four regions, right? So we can create a table called region 1, region 2, region 3, and region 4. And in the case of the region 1, could be the southwest. Okay, so if we assign the southwest to the region 1, then in this column, we will use the southwest as the number 1 and the rest of the region to be the number 0. So you can see that in this case, only the southwest will be assigned as the number 1 and the others are 0. And likewise, in the region 2, we will assign the region southeast as the number 1 and the other regions are 0, and so on and so forth. So you probably think that, okay, so if we have this dummy variable, then we could implement all these four dummy variables into the regression model. But that is a tricky part, because you can think that when you have this region 1, 2, 3 information, you already automatically include the information of the region 4. Why? Because when you give the first three region variables into the regression model, it will compare the southwest to the rest of the areas, and the southeast to the rest of the areas, and also the northwest to the rest of the areas. But also, if you include these three variables, it will also include the information of the region 4, right? Because you have already three regions of information, and of course, the rest of them will be automatically compared in a regression model. So that's why in the dummy variable, although in the categorical variable, when we create the dummy variables, we can create for each regions, but in reality, we only need three of them to represent the all information in the categorical variable. So in this case, we can delete the fourth columns and only use the information in region 1, 2, and 3 as the predictors in the multiple linear regression. So that is very important, but also the tricky part in the analysis of multiple linear regression. So I use this example because it includes the continuous variables, the ordinal variables, and also categorical variables. So include almost every kind of the variables that you need to learn in the multiple linear regression. Okay, so how to do this? Then we can see that we have the region information in the sixth column of the table. So similar to the sex and the other two binary variables, that we can extract the region information from the second row to the final row in the sixth column of the table. And we can further extract the single region information by compare the string to like southwest, southeast, northwest, and northeast. And so in this course, then we will create 4 dummy variables, which I name it these as SW, SE, NW, and NE. So in the SW, the result would be that the number 1 represents the southwest, and the rest of the areas will be 0. And likewise, similarly in other dummy variables. So remember that we only need 3 regions of information to include in the multiple linear regression. And you probably want to ask, so we should include the first 3 or last 3 or any of the 3. That is not that doesn't affect the result actually, but you can only include 3 of them and to see the result. Okay, so the next step is we will combine all predictors and response into a data matrix, and we simply combine all variables we created or extracted from the raw data, then combine them together into a numerical data format. So in this representation comment, that I just simply want to convert all data, including the numerical and the text data, into the numerical data only. So that's why I want to convert the sex to 0, 1. I want to convert the smoking status into the 0, 1. I also convert the region variables into the 3 dummy variables. So these are all the numerical variables. Okay. So once we have the data, and the rest of things that we can apply the generalized machine learning workflow to the new data. Okay. So this is the overview of the generalized machine learning workflow. Again, the first thing is want to divide the data into the training and testing subsets. So using the codes I already showed you in the previous class, then we can use the rand sample functions to divide the data into the 70% of the training and 30% of the testing subset. And so in this case, I can just simply divide the data into the training and testing. Then we will fit this data with the multiple linear regression. And remember that because we only use the 3 of the 4 regions here, so we only need to include the first 8 variables, 1, 2, 3, 4, 5, 6, 7, 8. We don't need the northeast regions of information, because once you include 3 of them, then the rest of them are already included in the table. So in the first parameters in the fit LM, that would be all cases with the information from the first column to the 8th columns, excluding the last region. Okay, and the response, which is the second parameters of the fit LM, should be the insurance, which is also the last column of the trained data. Okay, so when you execute this fit LM function, then you can use this trained model to predict the response in the testing data. Okay, so in the testing data, we simply use also the first column to the 8th column, use this information to predict the outcome of the insurance claims. And so this will be specified as a Y predict. Okay, and then we can evaluate the model, compare the root mean square error in the training model, and also the results of the training model when it is applied to the testing data. Then, so here you can see the result is that the root mean square is around the $600. So that is much smaller than what we have in the simple linear regression. It means that when we include more variables, the model can fit more perfectly with this kind of data, and so the error is smaller than when you include only one variable. And also you will notice that the error in the testing data is comparable to the error in the training data. So that means our model does not have the problem of overfitting. Then you can safely use this training model to apply in the real world data. So that is the whole whole essence of the machine learning workflow. Because in the final step, you want to know that if you can apply this model to any kind of new data, sometimes you may need more testing data to make sure your model can work in every situation. So that is the most important part. Okay, so let's take a look at the results of the multiple linear regression. So in the multiple linear regression, just I already showed you the output of the multiple linear regression in a MATLAB command window. I just copy and paste this region into my slides. So in the Model 3, the output will first give you the regression equation. So the Y is the response, which is the insurance claims in our case. And the number 1 represents the intercept, which is the y-intercept when the x, all other informations are 0 or are at the 0 axis. Okay, so we have, in contrast to the simple linear regression, we have the 8 variables in the multiple linear regression. And so this is a little bit difficult to interpret, because when we use numerical data in the fit-ln functions, we didn't specify the name of the variables. So it will just give you the order of the variable, which is x1, x2, until the x8. But in the estimated coefficients, then you can see that there are different level of the significance for each variable. For example, it seems like the x1 is very significant in predicting the insurance claim, and also the x3 variables, and also the x5 variables. And for others, you can see that the p-value is above the 0.05. So in the statistics, if we set alpha at 0.05, then we will consider these the data. For example, x2 is not useful in predicting the insurance claim, and also like the x6, x7, and x8. So if you remember that these 3 regions, these 3 variables are represented regions. So although for x7 it seems the p-value is close to the significance level, but if you set alpha, you still need to say that it is not significant. It has only borderline trend. Okay, and also x4 seems to be significant because the level is below the 0.05. Okay. And then you will find that there are a number of observations in this model, which is 937 cases, and the root mean squared error is the 612. So it's quite a small errors when you just include 8 variables. And you can also see that the R squared is much higher than the simple linear regression. R squared here means that as I explained in the previous class, it represents the ability of the model to explain the variance of the data in the response variable. So to put it very simply, it's just say that we have the model can explain 75% of the cases in our data. Okay, so and also there's adjusted R squared is dependent on the number of the cases, and also we have the evaluation of the whole model. The whole model is the p-value is very small. It means that the model is really significant because it just gives a very good explainability of our data, which is 75%. Okay, so the question is that because we give the model the numerical data and we didn't specify the names, so it's not very straightforward to interpret this result. But for now, we just go back to our slides, the previous slides, because we already know that X1, X3, and X4 and X5 are significant in predicting insurance claim. So what are these variables? So in the previous slides, we show you that the X1 is age, then X3 is the BMI, body mass index, X4 is the children, and X5 is smoker. So we now can conclude that the age, body mass index, and children and smoker are significant to predicting insurance claim. And that is reasonable because, of course, in the older age, we'll have the larger the medical expense. So you will have a higher the insurance premiums. And that is the very common case in the society. So that's why in the society, we want to create a program like in the United States, which is Medicare. The Medicare is the specific insurance program for the older persons. So they will not dependent on the very huge insurance the burden. Okay, so the age is the predictors of insurance claim, and also the body mass index is another predictor because the larger BMI means that you may have obesity problems, and the obesity can link to many medical disease, including the hypertension, diabetes, the risk of stroke, and risk of the cardiovascular disease. So that is the very important predictors of the many medical diseases, and of course, the larger BMI will will result in a higher the insurance claim. You might argue that the lower BMI, for example, the patient with the eating disorders may have a very low weight, then you will see the very low BMI, and that is also a problem. So, but because the most of the people have the obesity problem compared to the number of those with eating disorders. So BMI is generally positive correlated with the insurance claim. And the number of children, of course, the more children you have, then you need to, you will have more medical expense. So that is the common sense. And also the smoking status is common sense, that the smoking can lead to many medical disease too. And also related to the poor, like a person, poor self-care conditions. So all this information that is makes sense to predict the insurance claim. Okay, so now I want to give you a better version of this model, because as I said, when we put all numerical information into the model, then it's not straightforward to see which variable is which one. And so it's better that we can define the name of the variable in the beginning of the data. So to do this, the MATLAB can create another type of the data structure, which is called table. The table structure is very similar to the Excel table. Then you will just include the variable names in this kind of the data structure. So also in this case, we don't have to create the dummy variable for the categorical variable. The MATLAB can automatically handle the categorical variable for you. So in this case, we don't need to divide the region string into the southwest, southeast, or the other regions. We only just keep the region string as the original format. So we will input the age, sex, BMI, children, smoker, and the region string and insurance. Then we will give their variable names followed by the name of each variables, the age, sex, BMI. And remember, in the MATLAB, you can see that we use the comment to separate each variables. Then we will use the single quotation mark to specify this is the string. So, for example, when you specify the number of variable here, then when we want to specify the variable names, then you need to tell MATLAB, okay, so here I want to enter the variable names, and then with the comment, then you can input all these variable informations in the following parameters. Okay, so this data can create a table data structures. And so please study these data structures and the way we input the data here, and so you can understand the logics and the data format of the MATLAB programming language. Okay, so when you have chance to access the R or Python, then probably you will have used different formats. Just like you want to learn English, or you want to learn French, and you want to learn Chinese, and you want to learn Japanese, they all have different grammar and different language formats. So in the programming language, you have also this kind of problem. And so, but the reason I use MATLAB is because it has a very structured the functions and data format, so we can use a very simple few lines of code, and we can do many things. But if you have time, you might want to learn how to do the same thing in the Python or R, because that is also very hot areas and hot programming language in the data science. Okay, so when you have the table data, then the rest of things are very similar. You just also use the rank sample functions to divide the data into the training data and the testing data. And the difference is that in the training data and testing data is still the table data structures, is not numerical only. Okay, so here then we can fit the training data with the multiple linear regression. Then here we just only need to specify which one is the response variable. So when we put the training data here, we only need to tell MATLAB that which variable is the response variable. In this case, we just specify the response VAR is the insurance variable. So you just tell the MATLAB what's the variable name should be the response variable. Then we will consider the other variables to be predictors. And because we also don't need to create a dummy variable for the region strings, the fit LM will handle the region string automatically as the categorical variables. If you are not sure that this will work, then you can also specify the categorical variables in these functions, but you can look up in the documentations to do this. But for simplicity, I want to show you how to specify the response variables in this case. Then here I just need to change this one. So here then, oh no, I don't need to change this one because, so here I only show you how to okay, so I paused the video because you can see that immediately I found an error in this line because I still keep the previous the equation here, but in the new data format, then I need to change a little bit how we predict the model. So in this case, because we already know in the model which one is the response variables, so we don't have to specify this again in the predict functions. We only need to tell which our training models, and also we can put into the testing data. Then it will automatically use the predictors to calculate the predicted variables here. So you can see that using the table data structures, the code can be more simple. Then the final thing is that we want to evaluate the model. So here you can see the evaluation can be done with the difference between the predicted values and the insurance data in the test data. So in this case, because it's the table data structures, so I can use the test underscore data dot insurance to specify the insurance variables in this test data table. Then you can see the result is still quite similar to the previous one. Again, I want to let you know that because we have a rand sample function here, so each time you divide the data into the training and testing, it will give you the random distribution of the training and testing subsets. Then that's why each time we have got a little bit different results here. But it's comparable because you can see that the training model, the error is around $614, but in the testing it's even smaller, it's $589. So that is the comparable results with the model we use the numerical format. But also it's also comparable that the error is much smaller than what we have in a simple linear regression. So let's take a look at the improved interpretability of the multiple linear regression using a table data format. So in this table data format, we can have a more straightforward representation. So the linear regression can be expressed as insurance is dependent on the age, sex, BMI, children, smoker, and region. And then you can also see that the p-value is quite small for the age and BMI, and also very, very small for the smokers. Means that you can see that the smoker has the highest t values. Means that it has a strong chance that the smoking as non-smoker can determine the outcome of the insurance premium. So the second one is the BMI, body age, and the third one is the body mass index, and the fourth one is the children. So children is also significant, but it's not the very strong predictors. And also in this case, you can see that regions, still there's a region that maybe can be significant from the others. For example, the northeast regions, maybe still the premiums here is generally higher than the other regions, because in the northeast it usually has the higher income than sometimes corresponding to the higher insurance charge. Okay, so again, you can compare the R square value here, and also to look at the overall performance, overall significance of the model, the regression model here. So that is the multiple linear regression. And using this medical insurance data, then we can practice the different type of variables, which is continuous and binary, ordinal, and the categorical variables. And that is very important practice. I hope you enjoy this practice and you can apply this workflow to your own data. Okay, so I hope you enjoyed this workshop, and then in the next course we will continue on the lectures of the how can we use the brain MRI data to predict the age, brain age. So that is a very interesting topic. So thank you very much.